This video is over Lesson 72, Implied Ratios, and is for my 7th grade math class. In many ratio word problems, the ratio is clearly stated. However, there are times that two groups have a proportional, equal ratios, relationship without a ratio being clearly stated. In these instances, the problem will often describe two situations. One where both amounts are known. This is the implied ratio, hence the title. And one where only two of the amounts are known, or excuse me, only one of the amounts are known. These situations are called cases in math. Thus, to solve these problems, we will use modified ratio boxes. Since there is no ratio clearly stated, and both of the cases are actual real-world numbers, the two columns are renamed case 1. Usually this is the situation where both of the numbers are known. And case 2, usually the situation where the unknown number is. So here's going to be our ratio box. We're still going to label things group 1 and group 2, but the top will always be case 1 and case 2. And so if we fill in our numbers, A, B, C, D, then remember we make a proportion out of this. So if you can just imagine taking this box, once you've got it all organized, taking the box and imagining that being a sticker and just pulling that sticker off the page, putting in some fraction bars, putting in an equal sign, you're going to get your proportion. So we're going to take a look at the practice problems in order to go through this lesson here. So you're going to want to open up your books to page 509. Go ahead and pause the video and get page 509. All right, here we go. We're going to start with letter A. Kevin rode 30 kilometers in 2 hours. So right there, okay, if I make my box, I'm going to leave a space empty up there so I've got room to put my labels. So case 1, remember, is the case where we know the two numbers usually. So right now I know that 30 kilometers is connected to 2 hours. So 30 kilometers is connected to 2 hours. So now let's find out what is case 2 then. In case 2, at that rate, so rate, ratio, so this is going to be the same relationship as this 30 to this 2. At that rate, how long would it take him to ride 75 kilometers? So in case 2, the kilometers is 75. But I don't know how many hours that is. So estimate the answer, then use a case 1, case 2 ratio box to solve this problem. So first of all, to make an estimate, I'm going to look here and say 30, and then times what would be 75, or at least close to it. Well, 30 times 2 would be 60, 30 times 3 would be 90. So if we imagine that being somewhere between 2 times 2 and 2 times 3, then for my estimate, I'm going to estimate that just like the 75 is between 2 times 30 and 3 times 30, that the number of hours must be between 2 times 2 and 3 times 2. So the estimate here is between 4 hours and 6 hours. So let's find out what it actually is. To make my proportion, remember, imagine just peeling this box away. If I peel that box away, I'll have 30 over 2, and I'll have 75 over x. We've been doing this a number of times recently, so remember that our first step is to cross multiply. So 30x, 30 and x are across from each other, 30x, should equal 75 times 2. Or 2 times 75, doesn't really matter what order that goes in there. So now I'm going to divide both sides by 30, and that will get rid of my 30 up there. So the 30 that I'm multiplying by with x will get canceled by the 30 I'm dividing by. That'll leave us with just x. On the other side here, I can do some reducing before multiplying now. So I might take a look at this and say, well, I know that 30 and 2 can reduce because they're both even. So this would be a 1, and that would be a 15. And then maybe you recognize that 3 goes into both 75, like 3/4, and 3 goes into 15. So I know that that's a 25, and this can turn into a 5 then. Oh, well, obviously 25 and 5 can reduce more. So that'll be a 5, and this will be a 1. So the end result is, well, 5 times 1 over 1. Well, that's 5. And since this is in the hour row, 5 hours, which fits with our estimate of being between 4 hours and 6 hours. Moving on to B. For letter B, if 6 bales are needed to feed 40 head of cattle, how many bales are needed to feed 50 head of cattle? So here we go. I'm going to make my box. I've got my case 1. I've got my case 2. And in this case, we're talking about bales and head of cattle. So I'm going to just abbreviate this as just head. Now we will have to give the full label when we put our answer down, so head of cattle, but head's good enough for the box. So in case 1, the two numbers that I know are related to each other here, I know that 6 bales will feed 40 head of cattle. So that's my case 1. Those are the two numbers that I know are related, and I actually know both numbers. Now in case 2, we're told that we want to know how much to feed 50 head of cattle. So head of cattle in case 2 will be 50. So I need to know how many bales that will be. Now that we've got it all organized, imagine just peeling away this box. You'd be left with a 6 and a 40. You'd be left with an X and a 50. Put in your fraction bars, put in your equal sign. There's your proportion. So now we're going to solve it. Cross multiply, so I'm going to start with my 40 times X. That's 40X. And then I'll have a 6 times 50. Now to cancel out this 40 that we're multiplying by, I'm going to divide both sides by 40. So the 40s are gone. That leaves me with just X. And then over here, I know that 10 goes into both 50 and 40. And then I know that 2 goes into 6 and 4. And, well, actually, that's about as far as I can go. So let's simplify this now. So 3 times 5 is 15. And then that'll be over 2. So 15 divided by 2. So if we cut 15 and a half, that is 7 and a half. Now X is in the row for bales. So how much is it going to take to feed that 50 head of cattle? 7 and a half bales. So again, where did the 7 and a half come from? It came from our reduced 3 times 5 over 2. 3 times 5 is 15, and then over 2, which is 7 and a half. 2 goes into 15 7 times with 1 left over. All right. And finally, to finish it off, letter C. Letter C says 5 is to 15 as 9 is to what number? So this is a little bit different. So for this one, I'm going to set my box up, and this is what's called an analogy. So you've probably seen analogies in English class. This is a mathematical analogy. So I'm still going to have case 1. I'm still going to have case 2, but now I'm going to have the first number and the second number in each case. So my first pair is 5 is to 15. So 5 is the first number, 15 is the second number. Then it says as, and then after the as will be case 2. So 5 is to 15 as 9, 9's the first number, is to what number? So I don't know the second number. So I'm kind of running out of room here. I imagine you probably are too. We're going to see if we can get this in. I'm just going to put this up here. So 5 over 15 equals 9 over x. Now, something I can do, if I notice it, is I can actually reduce my fractions. Now, we're not multiplying, so I can't reduce the 15 and the 9. I can't reduce before multiplying because we're not multiplying. But you can always reduce a fraction. So technically, if I go back up to A, I could have reduced 30 over 2. If I go to B, I could have reduced 60 over 40. So over here, I'm going to actually do that just to make my life a little bit easier here. So if I reduce these both by 5, this will be a 1, and that'll be a 3. And now we just have slightly smaller numbers for cross multiplying. And in fact, this does something kind of nice for me, because now 1 times x, well, 1 times anything is itself. So 1 times x is just x. And then on the other side, 3 times 9, well, we know 3 times 9 is 27. So 5 is to 15 as 9 is to 27. So if you can ever get 1 times your variable, that actually solves the equation very quickly for you. And that, ladies and gentlemen, is the end of our lesson.